My name is Professor TK the Chemist, and today we're going to discuss neutralization reactions. You're probably wondering, neutralization, what does that mean? Well, neutralization reactions occur between an acid and a base. When two of these formulas react together, guess what they produce? Salt and water. So on the screen, I'm going to show you what it looks like when our tummies are full because we've ate too much acidic stuff, whether it's pizza, pasta, tomato sauce, whatever the case may be. And then you have to reach for Pepto-Bismol or milk of magnesia. And when those two react together with the acid that's in your tummy, it's going to produce that salt and water to help neutralize that effect. Now, a neutralization reaction is typically between a strong or weak acid with a strong base to produce water and a salt. So that's another thing that you all need to keep in mind. Is when you have a strong or weak acid with a strong base, it's going to produce water and salt. Now, remember, an acid is any compound that can release the hydrogen ion H+ when dissolved in water. In most common acids, hydrogen is usually listed first in the formula, like HCl, hydrochloric acid, HBr, hydrobromic acid, okay? A base, on the other hand, is any compound that produces the hydroxide ion, OH, in solution. Now, the most common identifying key component of a base is the hydroxide ion is typically at the end of the formula, like barium hydroxide, BaOH. You know, in parentheses, the OH, and then there's a 2 on the outside. Okay? Sodium hydroxide, NaOH. Now, there are a few exceptions to the rules where when you're talking about writing a base is with OH, but there's 2 exceptions, NH3 and NH4. So keep that in mind as well. Now, I'm going to give you an example of how to identify a neutralization reaction. You have HCl, which is your acid, NaOH, which is your base. It produces NaCl, which is salt, and water. Okay, so that's one example that you can keep in mind. I also want to show you some other examples. Stay tuned. Now, take a look at this next example here where we have HCl, which is an acid, plus magnesium hydroxide, which is a base, producing water, which is water, and magnesium chloride, which is your salt. Now, if we have this particular example and we were told to, let's say, balance this reaction out, it's quite simple to do so. Now, I always tell students, I always warn them that whenever you're writing out a chemical reaction, particularly a neutralization reaction, and you see that there's hydroxide on the left-hand side, always rewrite H2O as HOH. Here's your example. So as you can see here, it will allow you to balance this equation out properly. Let me show you how to do that. So again, as I mentioned before, HCl is the acid, magnesium hydroxide is the base, H2O, HOH is water, and magnesium chloride is salt, okay? So first thing I'm going to do is write down my H, write down Cl, write down Mg, but I'm going to keep hydroxide in parentheses and keep that together because whenever you have what's called a polyatomic ion, you never want to separate them out. It just makes things a lot easier keeping them together, okay? So what I'm going to do next is show you how many I have of each element on each side, on both sides. I have 1 hydrogen ion on the left. I've got 1 hydrogen ion on the right. I've got 1 chlorine on the left, 2 chlorines on the right, 1 magnesium on the left, and 1 magnesium on the right. I have 2 units of OH on the left, and I've got 1 unit of OH on the right. Now, we're going to start first with hydroxide ions. So what I'm going to do is show you how to balance that out first. So here I have 2 That's the common, let's say, multiple between the 2 and the 1 on each side of the reaction. So what I'm going to do is multiply 2 times 1 to give me the 2 that I need to balance out my hydroxide ions. I'm going to put a 2 right in front of this entire formula here, and that's going to give me my 2 hydrogen ions and 2 units of hydroxide ions. And guess what? I need to balance out my hydrogens and chlorines because they both require 2 according to what was on the product side. So on the reactant side, I am going to put a 2 directly in front of this formula, HCl, and it balances out this neutralization reaction. So now I have this reaction here, and I'm going to put it in a cleaner format so you can see it. So here is my formula here. And I am going to go ahead and put in my coefficients. I have 2 hydrogens and 2 hydrogens here. I've got 2 chlorines on the left, 2 chlorines on the right, 1 magnesium on the left, 1 magnesium on the right, 2 units of hydroxide ions, and 2 units of hydroxide ions as well on the product side. And this reaction is balanced. So this is your neutralization reaction.